All right, welcome to the Explainer. Today we're going to talk about these tiny little devices that stand between your expensive electronics and, well, total disaster. From your phone charger all the way up to massive industrial motors, these are the unsung heroes that are always on guard. So let's dive into how they actually work. Okay, so first, let's talk about the bad guy in this story, uncontrolled electricity. See, every circuit is designed to handle a certain amount of current. But when something goes wrong, that slow, creeping overload you get when you plug way too much stuff into one power strip, or a sudden, violent short circuit, yeah, that's when things get dangerous. So what happens here is you get this massive, sudden rush of current, way more than your wiring was ever designed for. This can literally melt the plastic off wires, fry your expensive gadgets, and yeah, in the worst-case scenario, it can absolutely start a fire. So you need something to stand in the way of that electrical tidal wave. So first up, let's look at the old guard, the original electrical protector. I mean, this thing's been around basically since we started harnessing electricity. And its genius is in its simplicity. It's just elegant. So here's how it works, and it's so simple, it's brilliant. You've got this little piece of metal wire inside, engineered to be the weakest link. But the moment too much current tries to push through, that little wire does its one and only job. It makes the ultimate sacrifice. It just melts. Poof. And that instantly breaks the circuit, stopping that dangerous electricity right in its tracks. And that's really the main thing you gotta remember about a fuse. It's a one-and-done kind of deal. Once it blows, its job is done, forever. Yeah, it saved your stuff, but now you've got to go find a new one and replace it to get things working again. So this whole sacrificial design, it comes with a really clear set of pros and cons. On the plus side, they are dirt cheap, they're super simple, and man, are they fast. They react almost instantly to a big fault. But the downside is obvious, right? They're single use. Every time one blows, you're looking at downtime while you hunt for a replacement. All right, so now let's talk about the new challenger on the block. The thing you probably have in your house right now, the circuit breaker. Okay, so right off the bat, a circuit breaker is totally different. It's not designed to self-destruct. Think of it more like a really smart, reusable switch. It's got this cool two-part system inside. There's a thermal part that slowly heats up and trips if there's a gentle overload, and then there's a magnetic part that reacts instantly to the huge current from a dead short. Either way, when a fault is detected, click, a switch is thrown, and the power is cut. And that's the game changer right there, reusability. Once you figure out what went wrong and fix it, you just walk over and flip the switch back. That's it. No fumbling around for a new fuse. Yeah, it's definitely more complex inside than a simple wire, but all that engineering gives you a level of convenience and control that's just next level. So when you look at the pros for a breaker, it's all about being flexible and thinking long term. You can reset it so downtime is way shorter. And a lot of them are adjustable, so you can really dial in the exact level of protection you need. But of course, all that cool tech comes at a price. They cost more upfront, for sure. And in those really extreme, super fast fault situations, they can be just a tiny bit slower than a fuse. All right, showdown time. Let's put these two head to head and see how they stack up on the things that really matter. Okay, so this table really just lays it all out nice and clear. It's the core trade-off we're talking about. We're looking at a basic fuse switch versus what's called a molded case circuit breaker, an MCCB, which is a super common industrial type. First, check out the response time. A fuse, it's ridiculously fast. We're talking less than 10 milliseconds. For something like a sensitive computer chip, that kind of speed is everything. It's the difference between life and death for that component. The breaker is still plenty fast, don't get me wrong, but it's more in that 30 to 100 millisecond range. But then, and this is huge, look at adjustability. With that MCCB, an engineer can go in and completely configure its trip curve, telling it exactly how and when to react. A fuse, it is what it is. It's fixed. It perfectly sums up the choice, right? Raw, blazing fast but dumb speed versus smart, adjustable, reusable control. So it really boils down to this, doesn't it? Do you need a disposable bodyguard that's going to jump on the grenade instantly, no questions asked? Or do you need a reusable guardian who's a little more sophisticated and can get back on duty right after the threat is gone? So what's the verdict? Who wins this fight? Well, the truth is neither of them. Or, I guess, both of them. There's no one-size-fits-all answer. It is all about using the right tool for the right job. Okay, let's paint a picture. Think about a really high-stakes environment. Like a huge factory or a data center. Places where every second of downtime costs an absolute fortune. In a situation like that, one of these is the obvious choice. Yeah, in these places, the circuit breaker is king. No question.
Because they're adjustable, engineers can fine-tune the protection to match exactly what a big motor needs as its load changes. And the fact that you can reset them in seconds, heck, sometimes you could even reset them remotely from a control room, that's absolutely critical when every minute offline is money down the drain. So that higher upfront cost, it pays for itself over and over in reliability.
Okay, but what about the other end of the spectrum, the simple stuff? Think about, I don't know, the plug on your desk lamp, or maybe a simple hobby electronics project you're building where the load is always the same. In that world, our other hero gets its moment to shine. This is where the humble fuse is the perfect fit. The load isn't going to change, and if it blows, taking a couple of minutes to swap in a new one is not the end of the world, right? In that case, spending the extra money on a complex circuit breaker is it's complete overkill. But, okay, just when you think you've got it all sorted out, breakers for the big stuff, fuses for the small stuff, there's a plot twist. Because the world of fuses is way, way more complex than just a little piece of wire in a glass tube. You think all fuses are the same? Huh, not even close. See, the decision isn't just fuse or breaker. Once you pick fuse, a whole new set of questions opens up. You have to pick the right kind of fuse. And if you get that wrong, you might as well have no protection at all. First off, you've got to think about speed. You've got what are called fast blow fuses. These are for super sensitive electronics, things that'll get fried by even the shortest little power surge. But if you put one of those in something like a power drill, it's going to pop every single time you pull the trigger. Why? Because motors need this huge jolt of current just to get spinning. For that job, you need a slow blow fuse. It's designed to be smart enough to ignore that initial startup surge, but it'll still blow if there's a real sustained problem. And it gets even deeper. The actual material the fuse is made of, that's a huge safety feature too. That little glass fuse you see everywhere, it might only be rated to safely interrupt, say, a 35-amp fault. If the short circuit is bigger than that, the fuse itself can literally explode or create an electrical arc, which is a whole new problem. But a ceramic fuse, it's much tougher. It can handle way higher fault currents, keeping everything contained and safe when things get really nasty. And this right here is a perfect example of how specialized and serious fuses can get. These are called high rupture capacity, or HRC fuses. They are absolute beasts. A lot of them are actually filled with a special kind of sand to absorb the energy and extinguish that electrical arc when they blow. You'll find these in massive industrial settings, protecting grids where a fault can mean hundreds of thousands of amps. A situation where failure is, well, it's just not an option. So at the end of the day, whether it's a tiny glass fuse in your Christmas lights or a giant, sophisticated circuit breaker in a factory, choosing the right one is what keeps our entire world powered up and safe. It's just a great reminder, isn't it, that sometimes the smallest, most forgotten little components have the biggest, most important jobs of all.